Hi all. In today's video, we're going to be looking at our next set of landform features, which are those found in coastal erosional settings. Now, before we get too stuck into the actual coastal erosional features themselves, I wanted to spend a wee bit of time just quickly recapping, for the most part, some of the main erosional processes that we see in this setting. So, when we're talking about coastal erosional processes, we're talking about three main processes that we see. We've got hydraulic action, corrosion, and attrition. Now, corrosion, attrition, it's exactly the same as how we've discussed them every other time. So corrosion, when we've got bits of material, bits of sediment that are grinding up against themselves, each other, and cliffs, as it is in this image, and using that kind of sandpaper abrasive effect to wear themselves and each other down. Attrition is, again, rocks, pebbles, etc., being bounced off one another and off cliffs. And then we've got hydraulic action. Now, hydraulic action, we've referenced before. We certainly spoke about it in the hydrosphere topic, but we've got a little bit of difference with it in coasts, and that we kind of particularly talk about it with reference to cliffs. So if we've got a wave that slams up against a cliff, any cracks in that cliff are going to have air forced into them, and it can be a very kind of pointed process. It can be very, very forceful, the way that waves can do this. So we're going to have air compressed into that crack, and it's going to make the crack expand. As the waves move away then, the air's going to explode back out of the crack, and it's going to make little bits chip off. And again, the more and more this happens, we're going to see that the cracks themselves expand in size, and it undermines the integrity of the cliff. So it's just a reminder, remember these processes, remember that we're expecting that we will discuss them in more or less literally every feature that we talk about here, and we're always going to explain what these features, or what these processes, are. Now, moving into the actual landforms themselves, a bit of a hit list, as I kind of like to give you guys. We've really got four main features that we look at. We've got wave cut platforms, we've got headlands and bays, and then we've got cave, arch, stack, stump. Now, cave, arch, stack, stump is obviously kind of a procession of features that all form in the same kind of, through the similar set of processes. And in this, when I get to talking about it, I kind of squeeze in blowholes in there, but they're a little bit different, a little bit of a special case, and we'll talk about that when we get there. So to start us off, wave cut platforms. Well, what is one? Now, first, if you look at the image here, you can see this area here of low-lying flat rock, and that's our wave cut platform. And they always, or more often than not, form directly in front of sea cliffs. So what we're looking at, the wave cut platform itself is the flat area, and then we've got sea cliffs behind it. Now, how do these form? Why do we get these features? Now, first, we think if we are between the line of low water and high water, we've got an area where the waves are going to be constantly attacking the edges of the cliffs. As the water rises and falls, it's going to be constantly working on this area through all of our processes: hydraulic action, attrition, corrosion. As that happens, if we've got a point of weakness in the cliff, it might start to get expanded, and it might start to form what we call a wave cut notch. Now, that wave cut notch is going to get bigger and bigger, and it's going to start to undermine the cliff above it. And as the wave cut notch gets bigger, eventually we're going to have risk of collapse. We're going to see the cliff above collapse into the sea. Those chunks, when they're on the wave cut platform itself, really get worked at by the sea and get reduced into small pieces of boulders and rubble. And it's going to cause us to get this nice, consistent, flat area of rock that used to be cliff, with the cliff behind it. It's why sometimes you'll also find that occasionally you'll see this feature referred to as cliff sand wave cut platforms, because we talk about both of the features together. So reasonably short and straightforward, this one, but it's always a good one because it's quite short and straightforward. Next, headlands and bays. Now, with headlands and bays, we can split this into two subcategories. We've got concordant bays, and we've got discordant ones. Now, if it's concordant or discordant, the difference is in the geology on the coastline. If it's concordant, the geology forms layers parallel to the sea. If it's discordant, it's perpendicular. These layers form at 90 degrees, and that will change the method of creating our headland and bay landscape. First, if we're looking at concordant headlands and bays, we're going to have this layer of hard rock that's immediately next to the sea, and we're going to have a point of weakness in it, a crack, a fault, what have you. As that gets worked on by the sea, as that gets enlarged, it's going to be hard work because it's hard. It's literally hard rock that's resistant to erosion. It's going to get bigger and bigger with time eventually, and eventually it's going to make its way into the soft rock at the back. The soft rock at the back is going to then get eroded really in a really pronounced fashion, and it's going to make a really big bays. Once we've got these bays there, then we've got our concordant headlands and bay coastline. Now the other one we've got is we could have discordant headlands and bays, and this is where, I say, the rocks are perpendicular to the shore, and it's going to be hard rock, soft rock, hard rock, soft rock, or a variation of that. The point being we've got soft rock sandwiched between two bits of hard rock. Now those soft rocks, by virtue of being softer, are going to erode much more quickly than the hard rock. And again, in both of these contexts, remember, we need to bring in all of our erosional processes. We need to explain them all out fully. As our soft rock gets eroded back, we're going to see it forming large indents in the coastline, and those are our bays. The headlands are going to be standing out proud into the sea, and those are our headlands, our areas of hard rock. Now this is Lamlash Bay, Brodick Bay, are examples of these types of headlands and bays. On either side, you've got harder rock that's got the little bit of soft rock sandwiched in at the back of it. Our next feature and our last feature is, as we say, is caves, blowholes, arches, stacks, and then it will have stumps as well, should be on the end of this. And you can also see in this diagram, it mentions a couple other things. You know, we've got needles mentioned, which we'll talk about at the end, and it throws wave cut platform in here as well, just to show you what one might look like in this setting. We start thinking about, we've got a cliff. So we've got a cliff, we've got a headland, and on that, we're going to have the waves eroding it. And we're going to have the waves particularly eroding areas of weakness. So we could have cracks, we could have fissures, whatever. The point is that it's going to be getting eroded. And again, we're going to be talking about our different types of erosion. We're going to be talking about, let's say, hydraulic action, corrosion, attrition. So this is going to keep happening. And, you know, it mentions here that if it happens to be a sedimentary rock that the cliff is made out of, it's going to be literally littered with cracks. So it's going to be really, the water's going to be able to erode it very efficiently. Eventually that's going to keep happening, and we're going to have a cave form. So that cave's going to have the sea rushing into it and eroding it and making it larger. If that cave's got a crack or a fissure that runs up to the top of the headland, as the water kind of rushes in and splashes against the back of the cave wall, it can go all the way up and eventually erode its way out the top, and that forms our blowhole. Now blowholes are rare. It's not something that happens, you know, very often, because you need a fairly specific set of geological circumstances for one to form. If they are there and they keep getting eroded and they keep getting worked out, you can actually start to have the roof collapse in because it becomes unsupported. This keeps happening. So I've got my cave, it's getting bigger and bigger and bigger. Eventually, it's going to break through to the other side of the headland, and I'm going to have an arch form. Now that can be sped up if I've got another crack on the other side, and I've got two things kind of working together to meet in the middle. But regardless, eventually it's going to erode all the way through, and we're going to have an arch forming. Now, as that arch grows, the roof is going to become more kind of stretched out and out and out over the top as the sides of the arch get expanded. And what's going to happen eventually? It's going to collapse. It's unsupported again, and it will collapse in. And that's going to leave me with my headland. You know, here, this is going to be still my area of headland. And then this area I've got left standing out into sea we refer to as a stack. Now, you've seen earlier in the diagram it mentioned needles. Now, all a needle is a stack that's very kind of jagged and pointed. It's quite narrow. And what we can get is our final feature here, is we could get a stump forming as well. Now, you can see in this image, actually, it's quite a good representation where I've got lots of waves and whatnot happening around the base of the stack. That's going to erode this in. And it's going to mean that it's going to get eroded in at either side, and it will eventually become very top heavy. As that process continues, the top of the stack's eventually going to collapse into the sea, and it leaves us with a stump as the only thing that's left. Now I'm going to wrap this up here, guys. That's the last of our coastal erosional features. Now remember, I say key things. Make sure you write out full versions of these. We'll work on this in class when you've got an opportunity to enhance all your notes, etc. You'll get copies of these diagrams. and I'll show you kind of some of the schematic versions of the diagrams for drawing up on your own. But remember, big key important point is explaining those processes, making sure that we've offered a full explanation of what the processes are. In the next video, we're going to be moving on to look at coastal depositional processes and coastal depositional features. And until then, I'll see you guys later. Bye.